Hey guys, it's Professor Tiffany Martin with Medical Microbiology, and we are in Chapter 14. And last semester, I did this section of the PowerPoint on Zoom, and it was meh. I love this section in the class. In Zoom, not so much. So I'm going to go ahead and record a video, but this means that you are going to have to work harder, okay? So think about it. Don't just, passively listen. Go ahead and think about it because it'll make more of an impact, okay? So you do your part. So you should have already started epidemiology. There's a video for that. And then we kind of skipped these couple of chapters. And we've defined epidemiology as how a disease moves through a population. And so your case studies, I had you do this. I wanted to know not just how that pathogen got in and caused the disease in the person, but I wanted to see, well, who got the disease? Is it more likely to be in men or women? What's the cases in the United States? Is it found in tropical regions? That's epidemiology. When you look at the big picture in the populations, when we're talking about COVID-19, who are the high-risk groups and, what's going on now? That's epidemiology, and that takes some counting and some numbers. So that's what we're talking about here. All right, so let's look at these slides, and I wanted to find some vocabulary for that. So to the slides. All right, so that's the study of epidemiology. Let's define the terms incidence and prevalence, okay? Looks very simple on paper. Incidence, the number of new cases in a population during a specific period of time. So incidence, number of new cases diagnosed in a population during a specific period of time. Prevalence is the total number of cases. So that includes newly diagnosed cases and anyone that already had the disease in a given population during a specific period of time. So there is a difference between the term incidence, newly diagnosed cases, and prevalence, newly diagnosed cases plus anyone who had it existing, who had already had those cases. Now prevalence is people who actively have the disease. So you're talking about people, once you've recovered from the disease, you're not counted in prevalence anymore. If you pass away from the disease, that number is not counted anymore. So those are some things you need to know about prevalence. So incidence and prevalence. You do, if you're looking at a disease and you're comparing incidence and prevalence, you do need to be comparing apples to apples. So if you're going to look at a population during a specific period of time, you have to say, okay, the incidence of this disease in Harris County in the month of April, this is the year, that's what you're looking at. And then if you're going to compare that to prevalence, you need to keep that the same. Harris County, the month of April, whatever you're comparing. So you do want to compare the same period of time. All right, so if we do that and we graph it, you can see here that this is just a common type of graph that you can see. And epidemiology is all about the graphs. It's very visual. Really helps to put the numbers into some sort of graph to help us, our brains, to understand the concept. So here we have incidence, number of new cases, and prevalence. All right, so my question to you is, we see in this case there's a smaller circle, so a smaller number of cases that are in the incidence category than prevalence. So incidence has a smaller number. Can you think of a scenario where incidence meets prevalence? So I'll get out my whiteboard for this, and if we have incidence in the middle, and we have, I'll put an I in that, and then we have prevalence, which is a larger number, and so a larger circle. We have prevalence there. Can you think of a way I can get incidence all the way out to meet or equal prevalence? So take a second, and I'm serious, think about it. Can you do that? Okay, what'd you think? Yes or no? Can you think of a scenario where incidence can equal prevalence? Incidence, new cases, prevalence, new plus old. Can we get them to meet? Okay, so you can even do some of these questions in your groups. Incidence, if it's going to equal prevalence, if there are no pre-existing cases. So there weren't anybody that had old. So the time period you're looking at, there wasn't anybody that had the disease. Then incidence can be prevalence. Say we had a new breakout of Ebola, and before that, in this area of the country, in 2020, in this country, there was no cases of Ebola, and then suddenly that month there was 3 new cases. Incidence would equal 3. But so would prevalence. You didn't have any cases before, nobody had Ebola in the country, so you can create a scenario where incidence equals prevalence. Yes? Okay, so think about it. If you don't agree with that, you're going to have to talk it out with your study groups and think about it. But we can definitely come up with a way that incidence could equal prevalence. And that was just an example of how that would work. All right, can you come up now with an example where incidence is greater than prevalence? So think about that one. Okay, what'd you think? And again, talk it out with your friends if you need to. This is one that it really helps us to talk it out. Can we come up with something with incidence is greater than prevalence? So sometimes I hear people say, well, what if they die? And again, if they die, so say if you're looking at the month of January, on January 1st, you have someone with disease X, whatever that disease is, and they die on January 2nd. If you're looking at incidence and prevalence for the month of January, they don't have to be alive until the end of January. So if they had it on January 1st and the range that you're looking at is the month of January, then they'll count for prevalence. Incidence, if it was newly diagnosed in January, it'll count. So incidence and prevalence. So on January 1st, let's follow that one out. January 1st, I had one person that previously had this disease on January 1st, so that's one person. That would be prevalence. On January 1st, I had a new case. So incidence now for the month of January is 1. Here, let's write it out. All right, so January, I have one person previously diagnosed who has the disease. They got the disease in December, whatever, so I have one person previously diagnosed. So I'm looking at the entire month, but coming into that month, I have one person previously diagnosed. So that would count into prevalence. So my prevalence is 1. During January, I had one new case from that. So in this case, my incidence is 1. My prevalence is 2, right? New plus old. All right, so incidence is still lower than prevalence, so I haven't done that. If person number 1 dies during January, they're still counted in because I'm still looking at January. So that won't help me get away. Let's say somebody else has the disease. So I just had 2 new cases in January. So what's my incidence? Incidence is 2. What's my prevalence? 2 plus 1. So I still haven't gotten incidence greater than prevalence. Somebody else gets diagnosed. I now have 3 new cases in January. I still had that one person who was diagnosed in December. Incidence is 3, prevalence is 3 plus 1. All right, so as big as incidence is getting, it's never going to get bigger than prevalence, because every time I add a new one to incidence, I also have to add that number into prevalence. So the question is, can I ever get incidence greater than prevalence? No. All right, so think through that. Make sure you're on board before we move to the next slide. Again, because of the definition, newly diagnosed cases is incidence, newly diagnosed cases plus existing is prevalence. Prevalence is always going to be equal to or greater than. Now we can get it equal to. If I have a 0 up here, I can get it equal to that. But because of the definition, I can never get it bigger than that. Make sense? Okay, so hopefully you're on board with that. So let's start looking at some charts, because epidemiology is all about the charts. So let's look at the first one and see what we can get. We can see incidence is prevalence. We can see that incidence can equal prevalence, but it can't get larger based on these definitions. So let's look at a chart. Okay, so what do you see? All right, so take a minute. We just defined incidence and prevalence. We just spent a long time saying that incidence can't be larger or greater than prevalence. What is this chart showing you? So I want you to take a minute, figure out, go back to the other one, rewind the video if you need to, figure out what is going on and why I have incidence and prevalence here. So take a minute for that. Okay, so you either figured it out, and it's kind of a light bulb moment. Once you see it, then you're like, oh, yeah. So it's one of those things, you can talk it out in your study groups or whatever. So once you've seen it, you're like, oh, that totally makes sense. If you have not seen it and you're still staring at it, I hope you gave it some time. You know, don't just look up the answer. But my hint is look at the axis. Look at the y-axis. On the bottom, I have years. 1985 through 2015 is this chart. Look at the axis and see if that helps you. Okay, did that help? The orange line, which is incidence, is recorded in thousands. So each number represents 1,000. So this is 20,000 here, 40,000 here. If I were to look at a line, 1990 here, I'm getting maybe 40,000 cases, 41,000 cases of incidence. Prevalence, the blue line, is also represented in thousands, but look at the scale. 500, 1,000 here. So if this is 500, this first line here is 100,000. So if I go back to 1990 and go all the way across, I'm looking at maybe 80, 90, 100,000 cases, maybe at 90,000 cases in 1990 for prevalence. So 90,000 cases, new plus old. Incidence, what do we say for incidence? 40,000. 40,000 cases, new. 90,000 cases, new plus old, prevalence. You see what they did here? Okay, so you're either thinking, okay, that's tricky, or maybe even deceitful, and possibly. You know, we hear that that comment, numbers don't lie. Numbers don't lie, but the way you present numbers can lead our brains to jump to a conclusion. And in this case, at first glance, when we see this big, huge peak, we think, oh, that's a lot of cases, much more so than this one. It takes our brain a while to analyze and really compare and see what's different. So visual, graphs, tables, all of those things are very powerful. It can help convey information very quickly. It can also make us jump to the wrong conclusion. Now, in this particular case, I don't think this was deceitful. I think it was kind of space saving. I think that they were trying to kind of save some space and put these both on the same chart. I think it ends up being a little more confusing and for people who are not aware of things, kind of misleading, but I don't think it was a deliberate thing. Now, if we're talking about things we see in the media, things we see, out places, can it be deliberately misleading? Possibly. Is there an agenda that someone creating this data is trying to push? Possibly. That needs to be factored in. We see lots of numbers going on, lots of data. And again, it's not that the numbers are lying. That would be not only deceitful, but criminal. When you falsify data, that's criminal. But if you present it that can lead people to think a certain way, that may not be criminal, but it can lead your agenda. If you want people to think that there is a big spike in cases, number of diagnosed COVID cases, if you want people to think that it's getting really bad, change your scale. You can make that line, that climb, as big as you want it by just changing your scale. So when you're analyzing data that people are putting out, keep those things in mind so that you really know what you're looking at. Because again, if I change the scale, a number that looked like this, and I change the scale, it could look like this. Much less worrisome in fact. So if I want to, anyway, you can make people think a certain way based on these charts and graphs. So be smart when you're analyzing that. So that's something we want to look at. All right, so that's one thing we've already learned from that. Now let's go back. This actually represents a disease. Let's kind of work through it and see what kind of information we can get from this disease. Okay, and this incidence and prevalence over a period of time, 1985 to 2015. Now, we'll tell you this disease is actually HIV. So HIV, if you haven't gone through the case study on HIV, again, I urge you to go through all those case studies. But HIV is a viral disease, and it infects people, typically sexually transmitted. Well, not necessarily. It's bodily fluid, transmitted by bodily fluids. So you can get it sexually transmitted. You can also get it from blood transmission from that, not saliva, but from blood and sexual fluids from that. So it will lead to the disease we call AIDS. The viral infection at first is pretty mild. Most people may not even realize they have it. It's a mild fever, low-grade symptoms kind of thing, and then it goes away. But that virus is a latent virus, so it gets in, integrates into your genome, and it targets your T4 cells. Your T cells or lymphocytes are part of our immune system. They help you fight off disease. This virus goes along slowly killing off these lymphocytes over a long period of time. So later on, the late stages of an HIV infection, you're depleted from your lymphocytes, and the simplest disease will cause you to die. You're dying from these very diseases that nobody else will catch because their immune system fights them off. And that is when you have full-blown AIDS, and that's kind of a late stage. All right, so time period, this was a new disease in the 1980s. It actually wasn't new. There had some early reports of it in the 1920s and 1930s, but 1980s is where it really blew up. It got into countries, it got into sexual networks, and it rapidly spread. People didn't know how to protect themselves from this new disease. They didn't realize they had it, and so it was easily transmitted by contact transmission, person to person in the 1980s. First it was called the gay disease because it was spread very easily by homosexual sex, and so those networks seemed to have it quickly, but then they realized there were other ways that it could be spread as well. All right, so let's talk about that. So we know what that disease is. 1985, new disease. Just like COVID, we're trying to gather some information. Just like COVID, it's going to take some time to see these patterns emerge. So what's going on? What's getting the disease? So in 1985, incidence, number of newly diagnosed HIV infections was maybe 12,000. Prevalence, much less than that. So 1985. Moving up to 1990, we already pulled those numbers. New cases, they are growing. So now we had in 1990, there were 40,000 newly diagnosed cases. New plus old, maybe 80 or 90. Okay, so prevalence, there were people living with this disease. Incidence is climbing. 40,000 new cases, 60,000 new cases, 80,000 new cases. So each year we're getting more and more people diagnosed with this disease. What do we see about the prevalence? We are seeing people that have it before they're diagnosed. Prevalence is growing, but it's not growing too much. 80,000 new cases? People that had it, maybe 120. What's going on here? Well, remember, when you die, you fall off of the prevalence. People were dying with this disease early on. They did not know they had it until the very late stages, which is where the damage was done. And so they were being diagnosed in that late stage, and the mortality was high. Within a year, passing away from this disease was very common when you're diagnosed in that late stage. So this is what was going on in the early years of this disease. And you can see incidence was climbing high as people were getting tested. Now we get to some point, 1993 or something, and incidence is leveling off and declining. What does this tell us? All right, so this is number of newly diagnosed cases. So by 1995, number of newly diagnosed cases have dropped down to 50,000. We're not getting as many newly diagnosed cases. What do you think about that? Is it because the disease went away? Let's look at prevalence. Prevalence, new plus old. Prevalence is still climbing. The number of cases here is still climbing. By this late stage here, we did see the number of new cases falling off, and then it kind of plateaued. What happens there is that there was a big, huge testing program. 1980s, go get tested, go get tested. If you're in these high-risk groups, go get tested. And so people were getting tested. So people were being diagnosed at an earlier stage. Early on, people weren't being diagnosed until full-blown AIDS, and they didn't have that long to live. If you were diagnosed early on, you could live 5 years, 10 years with this disease before it started the effects on your body became fatal. So they were being diagnosed earlier, and so they were living with this disease for a period of time. So that was what was going on. As incidence fell, you got to the point where the high-risk groups were tested. They had been tested because of the campaigns, go get tested, and safe sex campaigns, don't share needles. As we learned how it was transmitted, there were ways to protect yourself. So then people were protecting themselves. So incidence fell off, number of newly diagnosed cases fell off, and then it did reach a plateau, which is pretty typical. You get to a point where there's going to be, if it's in the community and it is being passed around, you're going to get to kind of a plateau. So that's what we're seeing with incidence, and that incidence kind of stays at a plateau. All right, so let's look at prevalence again. So 2000, I have 40,000 new cases. I have maybe 200,000 cases that are prevalent, new plus old. So I am getting some new cases, but I'm getting people that are living longer. And again, we still don't have any treatments for this. They're living longer because they were diagnosed earlier, because they found out in 1990 that even though they weren't sick, they did have this disease. And so in 2000, 5 years later, they're still alive. That's what's going on here, and that's what these numbers are telling us. All right, so that's growing. All right, so if we continue to follow prevalence, incidence has kind of leveled off. What do we notice around 2005? Wow, a big, huge spike here. So numbers that were growing, steadily increasing, suddenly spiked. What does this tell you? There are more people alive with this disease. Incidence had fallen off, kind of stabilized. So it's not due to newly diagnosed cases. It's not some, music fest and everybody's spreading it around, it's not that. People are living with this disease. What happened? We found our first drug. We had our first clinical trials. If we go back to there, the first clinical trials came in, I think 2004. We saw some modest, definite improvement there. And then as it went widespread and became the standard of care, within 1-2 years, we saved tons of lives. Tons more people were living and not dying with this disease. And you can see that has continued to climb. All right, little spikes here. Any type of spike is something to be concerning. What's going on in 2009? Honestly, I don't know what is causing this spike. Newly diagnosed cases, again, had gotten pretty steady, but this is a definite spike, something to concern with. When you're looking at these graphs and you're looking at numbers, you're always looking for what information it will tell you about this graph. Okay, all right, so that is epidemiology. I'm going to do the next video on the next one because I know you guys like short videos. So we'll come back and look at another set of graphs and see what it can say. But do you see what we're doing here? That's it. So do the work, look at the graphs, be able to determine what it's telling you and follow the information. And don't get swayed by an agenda. Okay, I'll see you at the next video.